All right. So for what we've been saying, we said SQL, right? I mean, if you need to define SQL, SQL is a programming language that is used to manage and manipulate relational database, right? SQL is a programming language that is used to manipulate, right, uh, and manage relational database. Somebody is asking, sir, do I choose my SQL Workbench? Yes, my SQL Workbench 8.042. Please, you can refer back to the video I shared on the group, right? That will direct you very well on how to install it, right? I hope I've asked people who have used it and they said that it is well tailored. So I believe it will help you. Thank you, Mr. Godwin. All right, so like I was saying, SQL is a programming language used to manage and manipulate relational database. So there are some words that become so important for us to note, right? There is database, there is relational database, right? There is database, there is relational database, and I've been trying to explain what the database actually means, right? So I say that the database is an organized collection of data that can be accessed, right? An area. I try to use a common word. I mean, a layman word to say that a house where we just keep storing data. That is the database, right? But then that is just used as a layman way to understand it, right? And I painted it with saying that you are saving your money in the bank, right? So the bank, in the case of data, the database is the bank, in the case of data. The database is an organized collection of data that can be accessed, managed, and updated. So what that simply explains is that the data you are saving in that house, right, must be the database gives room for that data to be accessed at any time, right? You can manage it, control everything that occur around it, and at the same time you can update the data to say that, oh, this data is not valid, this information is not valid again. I delete it and I put in another one, right? So those keywords are very important when trying to understand what database is, right? So we say database is an organized collection of data that can be accessed, managed, and updated. And of course, there are two types of database, right? This is a kind of flashback to our last class, right? There are two types of database. We have the relational database. We have the non-relational database. We have the relational database. We have the non-relational database. So let me recall back to the definition of SQL so that you can pick something from there. So I just defined SQL to say that SQL is a programming language used to manage and manipulate relational database. SQL is a programming language used to manage and manipulate relational database. And we just said that there are two types of database: the relational database and non-relational database. So SQL only interact with relational database. I hope we are getting something. SQL interact only with relational database. The non-relational database are managed by another management system, right? Okay, they are managed by another database management system. And then the quick one to pick is we have the MongoDB. That is for non-relational database. We have the MongoDB. We have another one called Redis. Redis is spelled Reddis, Redis. But generally, we have Python. We have the application called Python that can manage both relational database and non-relational database. I hope you understand that. But SQL is designed to manage only relational database, right? So SQL is a programming language used to manage and manipulate relational, right? Relational database. Now, so coming back to understanding SQL better, so we just established that SQL is a structured query language and it is used to manage relational database. I've repeated this about many times just within this short time because I want it to sink and stay that there is relational database. And the question will be, what are relational database, right? So what is, because we now see that we have relational database and we have non-relational database. So relational database is the database system, right? Database system that are relational databases. They store data in the table, in form of a table, or so to say, they store data in a structured form, right? And when database or when data management is saying that something is structured, it is simply saying that it is arranged appropriately on a table. So it is only in the scenario of a relational database that you will be talking about rows and columns. So when when data are stored in rows and columns, we say that that kind of database system is a relational database. So the Excel that we'll be referring to over, from the beginning of the class is a typical example of how a relational database look like. I hope we are understanding it. But in the case of non-relational database, right? In the case of non-relational database, data are not stored on the table in a structured form, right? They are not stored in rows and columns. They are not lines, that divide. They are not stuff like cells or what have you, right? Data are just stored in something that looks like a sentence and separated with some form of delimiters. You understand? So that is non-relational database. So while SQL is used to manage relational database, there's another word called NoSQL database that is used to manage non-relational database. Right? I hope I'm trying to position those words appropriately for you so that you can have it, stays in our memory, right? So we just said that SQL is a database management system, or generally, before I go there, there's another word we call the database management system, right? Database management system. That is the system designed to manage database, just as the way the name implies. The system designed to manage database. It is called DBMS. Sorry, not R. DBMS. DBMS simply stands for Database Management System. So SQL is a database management system. That is, it is a system designed to manage the database. I hope we get that. It is a system designed to manage. It is a system designed to manage the database, right? So while SQL is designed to manage relational database, we also have NoSQL that also manages non-relational database, right? SQL manages relational database. NoSQL manages non-relational database. And because of that, because SQL manages relational database, SQL is called RDBMS. That is Relational Database Management System. You understand? And we also have NRDBMS. That should simply mean non-relational database management system. So what it means is that SQL is RDBMS. Redis or MongoDB is a non-relational database management system. right? So generally, generally, we agree that we have more of no SQL. I mean, we have more of non-relational database that exists when you compare to relational database. So more information are stored, or more data occur as no structured, unstructured database than the structured database that we have. So about 80% of data that exists today is fall under under NoSQL. It is just about 20% that fall under SQL. So that people are studying SQL, talking about all of that, right? They are mostly they are just studying, because we study more of. I mean, what is common today is to study SQL, is to study structured structured database management system or relational database management system. And that is just about 20% of data, that exists when you compare to, how data are being managed, right? I hope, we are getting, the use of my word, or we are getting what I'm explaining. All right. So that is what SQL is basically talking about. SQL that we are focusing our attention on is is a relational database management system, right? And I believe we understand what RDBMS, what it means, right? We also have the NoSQL, like I said, but attentions are not on NoSQL at the moment, right? We are not focusing on the NoSQL, right? Usually they are not. To discuss NoSQL is another field entirely. Is another field entirely that we pay attention to, assuming we are getting into data science, right? Data science is what looks like the advanced level of database management that discuss where we now get into machine learning, robotic engineer, and all of that. So in that regard, we pay attention on NoSQL as well, right? But for data analysis, right, our attention is mostly on SQL. Right. I hope we understand. We have understood that. I'm talking about the relational data, the RDBMS. That's the Relational Database Management System, right? That is where we now talk about the system that we use to manage SQL, that we use to manage structured database, right? And one of that system is MySQL. So there are some words that we are explaining together now that look so similar. I've talked about SQL, and I'm talking about MySQL. You understand? I'm talking about MySQL. I've talked about SQL, and I'm still going to. And you can see that we also have another one called MySQL Workbench. So 3 words, and we need to be able to differentiate those 3 words. We've had SQL, and SQL is the language itself that will speak to query the database. That's the structured query language, right? The language itself will speak to the database to control it, to manage it, to query it, to ask questions, to say, give me this, and it gives that to us. That is SQL, right? MySQL, right, is the relational database management system. This management system itself, right? The query language is SQL. The management system to manage relational database is MySQL, right? And lastly, we have the application, the software, that we use to manage the MySQL. And that application is called MySQL Workbench. So I've explained 3 words that confuses people. SQL is the language, data structured query language, the language you speak to the database. MySQL is the database management system. MySQL Workbench is the software that you use to manage the management system. The software itself, the system itself that permits the management system to operate. That is MySQL Workbench. And that is why it is MySQL Workbench that we have downloaded on our system, right? That is the software we'll be using to manage the management system, the SQL, right? So there are several management systems apart from the MySQL, right? We have other ones. Oracle has its own. We have Oracle. We have MySQL itself is from IBM, right? IBM is the company that designed MySQL, that management system. So Microsoft also has its own, right? Of course, Microsoft calls its own Microsoft SQL Server, right? It also has Microsoft Access, right? Now, IBM has MySQL, right? It also has PostgreSQL, so we also have PostgreSQL as well, right? Then Oracle also has its own. So it is not, MySQL is not the only database management system that we have. We have more. That's what I'm trying to say, right? And at the same time, MySQL Workbench that we installed on our system is not the only application that is used to manage database. It is only the common one. Oracle also has its own. MySQL Workbench is designed by IBM, like I said. Oracle also has its own, and that one is called Oracle SQL Developer. Microsoft also has its own. It is called Microsoft SQL Server Management Studio. You understand? So there are so many of them, and those are not the only ones. There are so many of them that have existed. You understand? But I'm just mentioning them so that we can understand what they all mean at the same time, right? I hope we are catching up with the class. Now let's get into our software appropriately, right? We have all downloaded it, and if you launch it, right, this screen that you are seeing now is the first thing you will see. It will welcome you and say, "Welcome to my SQL Workbench," right? And I explained that MySQL Workbench is the application, this application that we are using to manage the database, right? That is MySQL Workbench. Now, if you look at this side, I'm introducing us to the application now, right? If you look at this side, you will see that you have two things here. We have my SQL connection. We have local instance. So usually, as a data analyst, right? Let's say, for example, now I'm a data analyst, and I've been invited by an organization to come and for consultation, right? To come and check some things with the database, right? And then I need to gain access into their database that already exists, right? So when I get to the organization, obviously there would always be somebody who is the database administrator or the database engineer in the organization. So that person needs to allow my access to the database, right? So if I need to access that database like that, I will come to my SQL connection here, right? You don't have so many work to do. The owner of that database, right? That is the administrator, right? So I only tell the person to give me access. And what will be done is that the person will click this area, and as soon as it clicks it, this dialog box will come up, right? Set up new connection. So I don't need to do any work. I just need to give it to the person. The person will will respond to this question. Connection name, that is the connection name, right? You will put in the connection name, you put in the password and all of that, and you will, once I say okay, I will have access to the database. Then I can begin to query that database, right? But then this is not an area where we want to work at the moment, right? Where we are going to now is to get into the interface of the workbench, where we'll begin to write the query and all of that to begin to communicate to the database. And to access that, you come to this local instance MySQL, right? And once you click it, for some of you at this point, it will request for a password. There's a particular password that was requested when you were installing the database. there's a particular password that it was asking you, right? That password I said is very important. You must hold it. So at this point, it will ask the password. I have set my own not to request for the password. That's why it's not requesting for it, right? So it will ask for the password. You just put in the password. You just put in the password, and then it will give you access, right? I hope you are following.
Sir, please can you explain that this last one you just I'm lost too. I've launched into the workbench already.
Please,
But
I can't even get the workbench. It's giving me the program page.
All right, I can't hear you. What do you say? I can hear you, Ms. Damilola, but bro, Mr. Benga, let me hear you.
When I try to open my SQL, it's giving me the program page. That's blank, black, where you as if you want to write a code.
Okay, no, that's not where we should see issue. It will load. Let you wait. Let's wait for a while. Maybe it will launch to the appropriate space. But Ms. Dami, what do you say? What's the issue?
Sir.
Yes. I was not the one. No.
It's me, Kwelumi.
Oh, Sister P. Oh yeah.
Yeah, so I can see after installation, I can see the welcome to my SQL Workbench.
Okay.
So I don't know what you clicked on.
Okay, click the local instance.
Okay.
Have you clicked that?
So yeah, so it's requesting for the password I chose. Okay.
Yes, so put in the password.
Should I save the password in also?
Yes, so that it will not disturb, it will not keep asking you everything.
Okay, sir.
Have you done that?
Yes, I am.
All right, that's fine. So so
would that be all?
Yeah, that will be all.
All right, sir.
All right. Sorry, I'm trying to attend to someone also here so that the person is able to download. Right. Please give me a few seconds. All right, sorry. I tried to open it for someone else. All right, that's fine. So once you put in the password, if you ask for the password and you input the password into it, it will bring you to this screen that we have, right? Is that what you're having on your system? Please confirm, everyone. Is this what you're having on the system? All right, that's fine.
Yes.
All right, that's fine. Okay. Yes, now, where we are now is called, this is my MySQL Workbench, and then it is, we have so many areas around it, right? Starting from the top, we have something similar to what we have on our Excel, the tab ribbon, right? But you can see that the tab ribbon here is quite different to the ones we have on Excel. The tab ribbons here we have on the tab ribbon, we have the edit tab, we have the view tab, we have the query tab, we have the database tab, we have the server tab, we have the tools tab, and we have the scripting tab, right? These are the tabs that we have, and when you click each of them, they all have their options. I mean, the functions that are in them, the buttons, and all of that, right? We have all of that are where we'll get familiar. I mean, we'll familiarize ourselves with it, right? We have the server where you will be able to connect to the client server, and then we have all of that. So this area is called the tab ribbon, something similar to what on the Excel, right? Now, if you move down a bit, you have three important areas, right? you will see that on the left-hand side, on the leftmost side, we have an area called the navigator, right? This is the navigator. And then down the navigator, you will see that that navigator is divided into two areas. We have the administration and we have the schema, right? Now, this administration, to start with, is an area it has functionalities to manage, that helps us to manage the database, right? In this area, we have functionalities that we can approach to manage the database itself. And that's why this area is more useful to those who are database administrator or database engineer, right? So they use this area more. So we do not really need to bother ourselves to what happens on this area, on this administration part, right? Of course, there are so many things we do with it, but then it's not what we want to expend our time on in the data analytics class. But then if you come to this other side, schema, that is the area that that's the area where we want to work, right? So this schema itself is like another word for database, right? And on the schema, you will see all this stuff that you are seeing here, right? You can see all this stuff. Each of them is a database. Those are the databases that I'm already working with. By default, on your own system, 3 databases will come with the system by default. 3 databases. We have the Sql. On your own system, you should have the Sql, you should have the world database, and then you should have one more. Please check your system. What do you have under these?
This.
Yeah, we have Sql, Word, and
This.
Yes, and sys. Yes. So you should have sys on your own system as well, right? So just for understanding sake, I mean for to test what you are doing, right? There are 3 databases that come with the system, right? So we have the Sql, we have the Word, and we have the sys, right? Now, if you look at each one of them, if you look at what you have, if you look at my own screen, right, you will see that the Sql is bold. Can you see on my own screen? Can you see that it's bold, right? It means that is the database that is active, right? That's the database that is active. So if I'm writing any query here, this is the area where you write the query. So if I'm writing any query here, it means that I am querying the active database. I am querying the Sql. So if I'm not going to work with the Sql, if I want to work with another database, if I'm not going to work with another database, right? Let's say I want to work on the awesome chocolate database. Maybe I get access to another database, right? Maybe I get to another organization, right? And then I try to connect to that database, right? The database will show, the name of the database will show here on this list, right? And when it shows on this list, I must make sure that it is bold, it is activated. To activate it, we write a language. The query language that we use to activate it is to write use, right? You can see that is, I want to use that database. So I say use, then what is the name of the database? So I'll say use, for example, I want to use this database, let's say world, because you also have word on your system, right? You don't have awesome chocolate. So we want to activate this database, world. So I will say use world, right? Use world. Now, of course, we are still going to talk about break down all these queries, how they are formed. But then for now I have said use word. It's just like you are speaking English, right? When you speak a statement when you write a statement in English, there is a way you show that you have ended that statement, right? In English, who knows what to write? If I've written a long statement and I want to show that this is the end of my statement, what do I do?
Full stop.
Yes, I put full stop. Yes. The same way it is in SQL. But in SQL, it is not a full stop that means that you have ended a statement. In SQL, it is semicolon that means that you have ended the statement. So if I write, like now, I have said use word, then I'm going to put in, at the end of it, I'm going to put semicolon. right? Like this, right? I'm going to put a semicolon like this, right? If I put in the semicolon like this, if I write in the semicolon like this, it will mean that I have written my statement, I have gotten to the end of my statement, and I am good to execute, right? But then that's the area we're still coming into, right? Let's not begin to write yet. Let's just look at how we can manage it from this area. So instead of writing using the use word, I can also come here to double click on that database directly. You know, this is Word, for example, this is Word. So if I want to activate Word, I can come here to double click it, double click. And you can see that now Word is now in bold text. You can see Word is now in bold text. Circular has become the normal text. So now the Word database is active. So if I'm querying the database now, I am typically querying the Word database, right? That is how to move, you know, how to select the database that you want to query. And that is done under the schema in the navigator scheme, in the navigator pane, right? Under the schema. You can see that obviously on the screen. So that is on this side, right? Now we have this other middle side where we are going to spend the whole of our time, right? So this is the Canva, right? This is the actual Canva where you write your query. Now you can see I tried to write one the other time. Then you know you begin to write everything you want to write. So this is the Canva, right? But then we are going to spend all our time on this area. So I'm going to leave it for now. Then we have this area on the right hand side that we call the SQL addition, right? We call this area the SQL addition, right? And it just have some other things that may want to come up, you know, maybe just things that it's just like the name implies, additions, right? They are not basically important now, right? But then as time goes on, we'll see how we need to use them. But then before we move off this area, you will see these three buttons here. Three buttons. One is showing a painted blue to the right. One is showing a painted blue to the downward. One is showing painted blue to the right and to the left. Another one downward, another one to the right, right? Now, this one that is showing a painted blue to the left is a button that we use to control the schema and the navigator. You can see that it is the navigator that is on the left. So if I come here and I click that button, it means that the navigator will go away. And you mostly do that if you need a wider screen, you know, when you are writing your query. So you don't want to see the navigator. It is still there, but you just want to keep it beside. You don't want it to disturb you, right? So we just control that area here. So if I click it again, it will come up. If I don't want to see it, it will go down. Then also, if it is this SQL addition that I want to do away with, right? If it is the SQL addition that I want to do away with, of course, we have this area. You can see this is the blue to the right. So once you click it, you can see that the SQL addition has gone away also. And now you can have a wider screen, right, to begin to write a query, right? And if I click this one, you can see that what I have under, right? That under is called the output, right? And the output has gone. Now, what do we do on the output, right? The output is where you see the result of any query you have written here, right? Any query you have written here, right, is going to show on the output, right? So if I, for example, now if I say use, like I wrote the other time, that use Word, even though it's not recognizing it now, okay? If I say use Word, right, and I say this database, use Word, if I execute this, whether the execution is successful, it is correct, or there's an error, this is where you will see it. It will show it on the action. And the action has four areas. The serial number, it has the time, that is how long it takes that query to execute. We'll see it just now, right? How long it takes the query to execute. Action, what did you try to execute? And here, the message, the ending message to say that your query is successful or your query has an error. So that's what we have on this output, right? Some write and they don't even bother about, they don't bother to know what the output is. It's not very important to them because they are, they have grown so well in writing the query that they know that anything they write will always be correct. So those people will most time want to do away with that output, and they will click this so that they don't have that page, that area, right? It's fine, right? It's just a level of how you have done so well with the query language. You are so familiar with it, right? But then it is important that we always keep it so that we see the result of what we are doing, right? Now, on this main page where we write the query, we have some areas at the top, right? We have some area at the top. Of course, this is to save any query we have written and all of that. But then what we actually needed the most is these two signs that looks like a thunder sign, right? Those two thunder signs, they stand for execute. They stand for execute. So if I've written the query and I want to execute it, something like I want to say enter, I'm done writing, and I want to say enter, I'll come here to click any of these two, right? Now you can see that they are different. There is one thunder sign that has like this I, capital letter I, right? There is another one that is just like that, right? Now the common one to use is this particular one, and that is saying that the query I have just written, the statement I have just written now, that particular query, execute it. But this other one, some people will write query, they are so sure that what they have written is correct, so they won't bother to execute it. They will go to the next query and write. So they can write a long list of statements. They will now want to execute all of them at once. You understand? So those ones, this particular execution button will work for that. That is, execute the selected portion of the script or everything, right? Sorry, execute everything. But this area will only execute the statement under the keyword cursor. That is, this particular area where the cursor is. You understand? Where this cursor is, execute that particular one. But this one will execute after I have written a long statement. You want to execute all of them at the same time. So usually people prefer to execute with this particular one, because as soon as you write something, it's important that you execute, because that particular query can be wrong, right? You may have grown confidence in yourself to say, yes, I can make mistake, and then you discover that one clause is actually giving issue. You understand? You won't know except you have run it. You have executed it as you write. You understand? So that is how these interface. That's what they all stand for, right? And of course, you can see that here I have SQL 5.6. So I have opened so many SQL view and the view tab, right? I've written queries on so many areas. So I have a new one that I've just opened where we are going to be running our own query in here, right? Okay, we're actually on this 4. Let me move it here. Yes. All right, we are on this area. So you can see this is the area where we are at the moment. So if you need to create a new view like that, you just come to File and you say New Query tab, right? If you do New Query tab or you use the shortcut Ctrl+T, it's going to open a new tab for you like this, where you can now begin to write the query. I hope we understand to this point that we are. Everything about this screen, I hope we understand it to the point where we are. Is there any question from any point? Are we good to go? Somebody should.
Yes, sir.
Yes, sir.
All right, sir. Thank you very much. All right, sir. That's good. Please, Mr. Benga, how is your SQL now?
It's not loading. Oh, I don't know why. It's still giving me that black program thing, that program page.
Maybe we may need to check it offline.
Maybe you click something else. I had that issue too where I was trying to open it.
Okay. It's showing me MySQL
supposed
shell.
to click MySQL Workbench, not the other ones.
I don't have MySQL Workbench on it.
It's supposed to be, I guess.
No, there's no. You have like MySQL Workbench. Okay, cancel it. Go to this search button here. Type MySQL.
Yes, that's where I went.
MySQL. Then it will give
That's
you will see
how I did it.
this logo. All right. Okay. Can you share your screen?
I can't.
You can't. Oh,
I
that's
can't.
we'll look at it together. All right. Maybe we'll try to check it off now, right? We'll try to check it off now. All right. Let's move a bit, another step ahead, right? Now talking about the database itself. From all understanding now, we have said that the database is an area where all data are stored in an organized pattern, right? Now, when we say data are stored, don't forget that SQL manages relational data. SQL is managing relational and structured data, right? Right. So the arrangement is in this order. We have database, and we have the data stored in the database, right? Please pay attention. We have the database, and we have the data stored in the database, right? Now, the data that is stored in the database, they are stored in a structured form. That is, they are stored in the form of a table, rows and columns. So it means that in every database you have tables. So when we say that database has plenty data, as it is said, it means that in one database we have plenty tables. Do you understand it now? Because those data are stored in a structured form. So if we want to discuss the database of an organization now, of a single company, of one company, right? So it means that in that database, we have a table that speaks to the employee, that we call the employee table, right? We have, that is, of course, that table will be particular, will be something that will be useful to the HR team, right? We have, of course, the HR team can also have several, plenty tables. Maybe one is just employee information. One will also talk about salaries and payment, payroll activity. One will also talk about their performance, right? So many tables that talks about employee data, HR data. In that same database, we'll still have some other tables that talks about the sales activity, right? We have sales in this area, sales in this country, sales in this state, sales in this person, all the salesperson, the information of the salesperson. We have several tables that talks about sales. We would have several other tables that talks about maybe the operations. We have several other tables that talks about supply chain, right? Warehousing, logistics, and all of that. So you can see that there are a lot of tables that we have, but all the tables, as plenty, as many as they are saved inside one database. So if you have access to open the database, let's take it to be a physical room that you enter. So if you enter the room called database, what you'll be seeing is table for this, table for this, table for this, table for this, table for this. So the order is in, we have database, we have table. Now, on each table, what you will also be seeing on each table is, in one table, for example, now, let's take, for example, employee table, right? Employee table that is going to be, that is a table for HR department, right? We have one that talks about employee information, right? Now, on that particular table, you have stuff like employee ID, right? On that table, that employee ID will be a column. Is that also? You have another column on that same table. You have another column that should be for employee name, maybe full name, or first name first, then other name, as you want to arrange it, right? But then we'll get to see as we move on that it is much more advisable and professional to break the names, right? To have first name first, other name, middle name, instead of having full name. You understand? But then that is beside. Maybe we'll be able to explore those activities, as we move on in the class, right? So we'll have on that same table, we have several columns on one table. If you pick another table also, you have several columns. That's what I'm trying to explain. So we have database. Inside the database, right? I'm picturing it to be like a room setting, right? So you enter a room, that room is a database. In that room, you will see tables, right? And let's take the table to be drawers. You understand? To be wardrobes. You know, just take it to be cabinets. Yes, let's take it to be cabinets inside that room, right? Now, on each cabinet, you have so many drawers. You understand? Which is going to be like the columns. Columns. So we have a column for employee name. We have a column for employee ID. We have the column for employee salary. We have the column for employee employment date when those employees. You understand? So we have, if you want to arrange it in form of in that hierarchy, we would have the database, then we'll have the tables, then we'll have the columns, then on the columns, we'll now have the rows, the actual information, right? Let me try to open an Excel file just to make us have something like a good picture of what the arrangement will look like, right? So let's just open an Excel randomly. Excel open on time. We don't have time to check time. 1 hour is gone already. Oh, this class is 2 hours today. Wow. All right. So why the Excel is opening, is loaded rather. So this is how the arrangement of the database is, right? Now, what we do now is to now, usually in the database, there are data in it already. Tables, okay? You can see my Excel has opened, right? And you can see from this particular one that that this is one.
Sorry,
like
sir,
this.
I'm not sure I can see your screen. No.
Okay, my Excel is not showing, so I have to share again. No
It's
worries.
not showing. It's only the SQL.
Yeah, thank you. You see it. It will show. Let me show all the screen. Right. Can you see it now?
Yeah, to display.
Okay, I can see the Excel
All right.
sheet.
So this is an Excel. This is the Excel sheet. You can see this is like saying that this is the table. One of it like this is the table, right? In our last Excel class, you know, I was trying to explain to you how is in your own class or another person's class how tables are recognized. When I was saying that, let's say we'll call this one employee ID. We'll call this one, let's just use full name for now. Full name. We'll call this one employment date, right? And let's say lastly we have salary. And let's just put department as well. This can be a table. You understand? So we'll now begin to populate this information, right? This can be a table, something like this. Let's just make it look a bit unique, right? Let's make this like this. This is a table. Let's make it bold. This is a table, and it is all of this. So this can be a particular table. You understand? So employee ID can be maybe 001. Maybe the full name is Olamide Maxwell. You understand? That's the full name. Let's say the department is let's say the department, let's use E001. Okay, 001. All right. Let's say the employment date is 0201, sorry, 020102 1900, right? And then let's say the salary is 1 million naira. Okay, is that 1 million? Yes, 1 million. All right. And let's say the department is let's say the department is IT, for example. You understand? So this is, you can see that this is a table, right? And these are the columns. These are the several columns in that table, right? This column is now, the rows is now mentioning the particular information of the column. You understand? So this area also is going to house the information about another person. This is for Olamide, right? We would have another one that will be for maybe Femi. You understand? We have another area that's going to give information about maybe let's say Joel. You understand? So that is how it is. So we have the place where the area where the whole of the table is stored, and we have all that tables also stored in it is the database. And what you will see in the database are tables like this. This table is one, there's another table maybe somewhere here, there'll be another table maybe somewhere here. So all tables are saved in that database. Now also in the table, on each table, we have the columns, right? The columns like this, the columns like this, the column like this. Now, and under each column also, we have the rows, the rows, the rows. I mean, these are the rows like this. These are the rows, these are the rows. So that is the breakdown of the arrangement. We have database, we have table, we have the column, and we have the row. You understand? So understanding that structure will help us to interpret so many things that we'll do, we'll do as we move on in this class. All right, that's fine. Now let's begin to talk about our statement, because like I said, we speak the query. Querying the database is about ordering a statement in that database, right? It's about ordering the statement. And if you recall in the last class, I said the statement that you speak to the database or the SQL statement are divided into 5, right? Maybe I should ask if you still remember, but let me just tell us, right? I said they are divided into 5. We have the DDL, data definition language. We have the data query language, right? If you remember, we have the DML, the data manipulation language. We have the transaction control language, right? And we have the other one, data control language. You understand? So those are the 5 query languages that we have. Now, let's begin to focus our attention on the first thing, right? And that is, let's say now the database does not exist, right? We just want to create a new database, right? Even all these database that we are talking about, the database itself is going to be hosted on a server. That's another thing that we're not even talking about here. We've talked about the table being in the database, the column being on the table, and the row making the columns. You understand? But the database itself will be hosted on the server. You understand? And usually there are 2 types of server, right? These are activities of cloud computing engineers and maybe a database and the administrator, right? That's why we're not mentioning it. We are not mentioning it here, right? There are 2 types of server. It is an on-premise server that is already getting outdated, or a cloud server. So the server is a physical location. No, it can't be a physical location again anyway, but it's a location. Usually it used to be a physical location, right, that we have in your company, where you can now manage the files, the information about the company. You understand? That is called a server. If you remember those days that we go to server cafes, right? They will say the server is down. Server is down. That is a one room that they have designed to begin to manage activities about what is going on in that area. Is down. That's what they mean. And it will begin to give issues about the how your information, the information you are transacting, right? How it begins to move, right? But these days, because of the perils of hosting a physical on-premise server, right? Most of the organization now deploy the server to be on cloud, right? On-premise server means that if we are using an on-premise server, right, somebody that is outside that organization cannot have access to some files that you have saved. You understand? It's like using all this all these olden days that they transmit wire, to make calls, all this wire telephone. You understand, right? But the cloud server, the invention of the cloud server means that I can be here and access a particular server that is in UK, right? And access the information, the database that is saved in the server in UK. I can access it from here. I don't need to be physical in that area. I don't need to be physically present in that area. That is the server. You understand? So the database will be hosted on that server, right? Now, that database usually will be created. You understand? We'll first of all create the database before the data can now begin to run into it. So it is important to understand how to create the database. And the statement used, the SQL statement used to create database is called create. You understand? Don't forget that I already said that by default on this workbench, 3 databases that comes with it: the sys, the word, and the circular. Let them be, right? We'll work on it. We'll use them as an example. But then, let's say now we want to create our own database. Let's call this database, let's call it amplified. Let's create a database now in this class using the statement. Let's call it, what should we call it? Let's call it amplified. Okay, so there's a database that will be called amplify, where we can now save the information of the amplified church. You understand? Let's create a database and see how it works. All right. Now, I just said that the statement that you use to create the database is called create. You understand? Just as it was. So I want to query I want to speak to the database to say that my database, I want to speak to SQL rather, to say SQL, I want to create a database that is called amplified. How do I do that? I'm going to write the query language, right? I'm going to write the statement. The statement is create. Can you see? I say create. Now, what do I want to create? You can create so many things, right? You can create, basically, you can create tables and you can create database, right? But then you can't create a database, you can't create a table without having a database. I can create a new table and put them under any of these databases that are here, right? But then I first of all want to create a new database first. So I'm going to state what I want to create. So I'm saying that create database. Can you see? Create database. Then I will now go ahead to put the name I want to call that database. Now I want to call it amplified. So I will say create database amplified. Can you see now? So I have just written an SQL statement to create a new database. And what are the words that you can see in this statement? We can see the create statement, right? We can see the database, and we can see the amplified. 3 things. And one of the things you will notice is that there are some of them that comes in blue color, right? One comes as a normal, right? Now, any word that you see that comes in blue color, well, in SQL, it means that that word already had been made to exist in that word exists in the SQL. For example, now, if you write in Excel, if you write sum is a function, right? So it will list it out. It means that Excel has been programmed to identify that keyword. You understand? So in SQL, there are some keywords that have been programmed into SQL to say that when you see this word, accept it. Don't forget that I said in the last class that it is not, there will always be a synonym to create. Is that not so? Can I get a screen origin? Can somebody borrow me a synonym for create? Anybody?
Make.
Create. Sir?
Make.
Okay, let's say, yes. Let's say make now, for example, now. Make. Now, if I say make database amplified, it looks like what is also correct, right? If I speak to somebody in front of me to say that create database amplified, and I say make database amplified, the person will understand easily. But if you speak to SQL, there is a particular word that has been programmed that understands this word. If they speak the synonyms to you, it doesn't concern you. So make is not a word that has been programmed into SQL. So even though make and create means the same thing, SQL does not understand make, but create has been programmed into it. You understand? So one of the things that we want to take our time to understand in this class is to understand those words that have been programmed for SQL to understand, which is create. So if you need to create table or you need to create database, you use this statement create. You use the create clause, right? Somebody is trying to ask a question. The person says, sir, is it safe for us to say that this is the same program that is used in ChatGPT. No, that's not the same program that's used in ChatGPT. All right. However, ChatGPT is not a query language anyway, but ChatGPT work by having some information in its own database. You understand? So the database, if you need to query that database that ChatGPT use, you will use the same query language. You understand? But ChatGPT itself is not a database. All right. I hope I answered the question. Now, so I've just written a statement to create a database, but this is not the end of that statement. I said earlier that there is always a punctuation mark, right? That will now mean that I have ended my statement. And in English, it is full stop, but in SQL, it is semicolon. Now that I have semicolon, it means that I have written this statement. I'm done with this statement. I want to create a new database, right? I want to create a new database called Amplified. As soon as I have done it, somebody want to ask a question?
Is it ready to execute?
Yes, ready to execute. Then I will click this button to execute, right? Now, I've clicked it. As soon as I clicked it, just come to this output. You can see the output now. The output has marked it. That is, what I have done is correct. It marks it. Then the time it takes, the time I did the execution, 21, that's 9:15. You can see the time here. That's the time I did the execution. The action that I did, I created a database called Amplified, right? And the message, that is, I create a one row affected. It's just one row, nothing much. I've not done anything deep, right? And that is what I have done here, right? So I have created a database called Amplified. So maybe if I want to use it now, maybe we'll begin to save everything we'll be doing in this class, right? We'll begin to we'll save it under that database called Amplified. Now, because we said this area is where the database we are working with, this is where it shows. Then it means that the Amplified that we have created is supposed to show here, right? But is it showing here now? No. So it doesn't mean that we have not done well, right? It only means that we need to refresh this area. And there's a refresh button here, right? Look at this button here. It's a refresh button. If you click it, it will refresh. And if you look at it now, if you look at it now, we'll have Amplified. Can you see now? Amplified is now here. Can you see? So I've created it. But yet, it is not active. It is Word that is active. So begin to work on that database now. Maybe you can see that the database is actually empty. Nothing is in it. I've only created it. So to begin to work on it, begin to create tables inside of it, right? I will need to activate it. You understand? And to activate it, I already told you that it's either you double click or you come to the query, to the tab, to the canvas, and write the query. Use Amplified. Right? I can say use Amplified and put semicolon. Now, I have written. Yeah, thank you very much. So it has to be correct. The spelling has to be correct. Yes. Now you will notice something, that there is a blue dot here, right? If you see this blue dot, it means that the query you have written is correct. You understand? If it is not correct, it will write a red cross. A red times, multiplication sign times. That's what you have it. So if you have that sign, that symbol here, it means that you need to check the query you have written. But as it is now, it means it is correct. So once I put my semicolon, it means that I am done with the statement, right? Then I'm going to execute. And don't forget, you execute with this, or you use Control Enter to execute. If you still do Control Enter, you can see now that Amplified is now bold. It means that now everything I will be doing will be, I'm working on that database called Amplified. Do you understand it now? So it's either you double click on it or you write this statement to say use Amplified. No, you can see that everything we are doing is just like we are speaking English. That is why it is nothing hard. You just speak English. You only need to understand the keyword that follows what you want to do. You understand? Now, if you look at the the database now that I have created, which is amplified. Look at this arrow. It means that it has some information into it. Now, inside the database, we have tables, right? Now, at the moment, let's check another one. Look at this particular awesome chocolate. Now, under the database called awesome chocolate, you can see the tables. The table still have arrows. That is, there are many tables into it. You can see it has 4 tables. You understand? But if you look at this amplified, there's nothing there. We have not created any table into it, right? Because there's no information into it. So the next thing to do now is to create information into it, right? So let's say we want to create, our time is getting fast, pen. Please get me a pen. So check my bag, there is a pen there. So we want to create a database, and we want to create a table for all of us in this class. My diary is there also. Bring my diary. Okay, don't worry. All right. Let's say in this class, just follow me as I'll be saying them. In this class, we have 14 people, about 14 people in this class at the moment. All right. You have, but then let's say we want to create a table for the people in this class, right? Let's say we have, let's say student ID. Let's say we want to have, of course, a table will have columns. Is that also? So let's have a picture of how the table will look like. It will have the student ID, right? Student ID. Then it will have, let's still use full name for now. It will have full name, right? It will have, let's say, let's pick a date. Let's call it date. Enrollee student ID, registration date. Let's call it registration date, right? Let's say we have gender, right? And let's say we have, the last time we have phone number. 1, 2, 3, 4, 5. Let's put one more thing. Let's say department, right? So we want to create that table, a table that has student ID, full name, registration date, gender, phone number, and department. So let's create the table now. Let's see how to create that table. Now, this time around, we have created the database, right? We have activated the database. Now, the database cannot work on its own. It is tables that will be inside the database. So now let's create the table. And let's see how to write, a statement to create a table in SQL. Let's have to write an SQL statement that will create a table, right? All right. Now let's say we want to, the name, of course, the same way the database must have a name, the table must also have a name, right? Let's call the name of the table, let's say student info. Yes, let's call it student info. So to create it now, I'm going to say, what is the keyword? What do I want to do? I want to create table, right? So my keyword is going to be create. What am I creating? Table. Thank you. So I'm going to say create table. You understand? Same way as if you are speaking English. Now, what is the name of the table? Student info. Look at it. Info. But in SQL, right? You don't put a space like this. So it's either I have it as student info or I have it as student underscore info. You understand? When you are naming them, we don't have a space. We don't put a space. You understand? So we have student info. And then I'm done writing that statement. But in the case of when you are creating a table. A table cannot always stay alone, like we have said. A table will always have its column with it. Is that not so? So we will create the column with the table, because the table must have columns. You understand? So we'll create the columns with the table. So after saying create table student info, we'll now go ahead, open the bracket to begin to list all the columns that the table we have. You understand? Now, the first column that I have mentioned that it will have is, you say that it will have student
serial numbers, names.
What do we call it? Student ID, right? Yes, student ID. Student ID, right? Written in that form, right? All right, student ID. Let's stay here first. Now, having said that, in the last class, we explained some stuff, right? We explained, we talked about, what do we call these things in the last class? Data type, right? Remember, we talked about data type, that if you are creating a column, you must specify that this column should take this kind of data. And this is done at the beginning like this, at the area when you are creating the table. To say that I'm creating a table, the name of the table is student info, and it will have all these columns, right? One of the columns is student ID. And that student ID, this is the data type that must be put into it. So here you will specify whether the student ID should be numbers or should be a text, a string. You understand? Whether it should be number string or it should be text string. If you recall, I said we have three particular data types. We have the character string, right? That is also divided into char and varchar. Also, we have the number string, where we have integer, big integer, tiny integer, float, and decimal number, and Boolean, and all of that, if you remember. Then thirdly, we have dates. Those are the three major data types that we have here. Now, student ID, what data type? You know, remember we were explaining the data type in the last class. So, which of the data type do you think student ID should be? Anybody wants to talk? Student ID, what data type do we think it should be? I want somebody to varchar.
I think it should be varchar.
Yes, sir. Why do you think it should be varchar?
It should be number now, maybe 001 or whatever.
Yeah. Usually, student ID used to be numbers, right? Okay. So if we want to agree that it is number, it means that we'll say that data type is a number, right? Now, I'm going to show this question. Our account number, is it a number? I think I've asked this question before, right? In this same class, right? So understanding the essence of the number is also important. Now, the reason why we need to specify the data type is that some operations can easily go on them. If you call that data, if you call it a number, it means that we are saying that those set of data information and data should be able to do basic mathematical operations. So if you have called it number, it means what you will have, you must be able to do basic arithmetic with them to say this number plus this number. You understand? That is why we call some data type. That's why we call them number. But if you look at account number, it is a number in the name because you use 00 numbers to depict it. But in the real sense, there is no scenario that will make you say that you want to perform basic arithmetic operations on account numbers. So we'll never say that my account number multiplied by Mr. Benga's account number. There's nothing we want to do with the results. You understand? So, of course, the same thing with phone number. So I won't say my phone number, that 11 digits, plus another person's 11 digits to get a particular. So they are numbers, but they are not actually performing the duty of a number. They are basically seen as an ID. You understand it? It's an ID, even though it is number physically, but the basic function they are performing is an ID. So account number is an ID. That is why two persons cannot share the same account number. Phone number is an ID. Two persons cannot share the same phone number. Your name is an ID. Two persons ideally should not share the same name. That is why we'll try to have so many names. You understand? That's why we have surname, we have the first name, we have the middle name. Hoping that even if your first name is between two people is the same thing, then we expect that your surname should differentiate you. And in the case where your first name and your surname is not the same thing, then you have another middle name that should differentiate you. So something must differentiate two people. So the same thing now, if you now find that both first name, second name, and middle name, first name, last name, and middle name are the same thing, then you turn to another thing to differentiate the person. Because usually those are the three names that we recognize, right? The first name, the last name, and the middle name. All the other names are just there, just so that you have names. You understand? Now, in the case where between two people, the first name, the last name, and the middle name are the same thing, then we'll now turn to, usually the next we can turn to, if it is in the case of employee situation, employee table, then we'll turn to the employee ID. So there is no way the employee ID of people in another two people will share the same employee ID. There is no way. But then basically now these days, before even turning to the name, the first thing we turn to is employee ID, because we know that name can be the same thing. You can have the same name and the same surname, but while you are being onboarded into that organization, they must ensure that you have a unique employee ID. So employee ID cannot be the same thing. You understand? So that is why you see that we started this table we are creating. The first column, we started with a student ID. So every table must always, is a must in data management, in data analysis, data management, anything that has to do with data. Every table must start with the ID of that table. So if you are talking about employee table, then there must be employee ID. If you are trying to create a table for sales, there must be sales ID. Because at the end of the day, it is that ID that will be a unique identifier of that particular role, of that particular information. You understand it? So the ID can be a number, but the actual work that it is doing, it is not performing the function of a number. It is rather performing the function of an identity, which is a text. So student ID, employee ID, even though they are number, they are usually a text. And in that case, we will not depict them using a number string or integer. We will use a text, a character string, to depict them. And of course, there are two types of that character string. It is either a varchar or it is a char. Now, in the last class, I explained the difference between varchar and char, right? I said one is variable character, the other one is ordinary character. Now, the ordinary character, which is char, is used for smaller digits or smaller number of text. You understand? So, which means in this case, student ID cannot be long, can never be long digit of number. Usually, it can be more than 6, 7, maybe 10. In worst case scenario, 10. You understand? So we are going to depict it with saying that student ID is a char, like this. You understand? And then we also state the length of the text. You understand? So maybe in our organization, our ID is not always more than five letters, or let's say 6 letters. To say, let's say amplify. Some people will say amp. People can write ID as amp 001. If it is taken for amplified, you understand? That is amplify 001. So how many letters can that be? Amp itself is 3, right? Then we now have 001, 002, 003. We also get to 0010, which is 4, and we can get to 0000. You understand? So maybe let's just say amp 4, 5. Maybe let's just say 8. It can't be more than 8 digits, right? So we always take the length and say, okay, let's just say 10. It can't be more than 10 digits. Do you understand it now? So you can see that for this student ID, right? We have defined, while creating that column, we have also defined the kind of data that it can take. So after I have created this thing, if anybody comes into it to put a number into it, it will not accept it. If you come there to put a date into it, it will not accept it, because we are defining that this column I'm creating should only take a text character or a string character. I hope we are following. Now, another thing that we also put into it before we end, still on that same column, is to put the what we call the constraint. So in the last class, I was going to talk about constraint, and I said I'm going to push you to this class, right? Can you see my screen? I'm sharing a PDF file now.
Yes, sir.
All right, that's fine. Now we have something we call MySQL constraint, right? And then constraints are just some kind of rules that you put on your statement, you understand, on the data to restrict them. Something like the data type also that we are talking about, right? And on this list now, I have just about 7 constraints, right? The first one is not null. Not null. Now, when you put, so in this column that I am creating, after I have specified the data type, I can also come and say that, put a constraint into it to say not null. And what the constraint is doing in this case is to say that, you see that column that is called, that I will call student ID. We must not have any of the rows in that column that will be empty. There must not be a null, there must not be a null row in that column. So if you are filling the information in the rows, right, you cannot say the first person is the first person have student ID, the second person has student ID, the third person does not have student ID. There won't be anything like that. There must be, as you are putting information into that column, each row of the column must always have information in there. Do you understand it? So that's the constraint. So a constraint called not null is simply saying that it is simply ensuring that a column cannot have a null value. It will never happen that a column have a null value. And we define it from the point of creating that column, from when we are creating the table. That is a constraint, right? There is another constraint we call unique ID, and that's the unique that I have here, right? Now, I've been explaining ID, right? Student ID, employee ID, and all of that, right? Those stuff, that particular term that I'm explaining is a unique ID. And what it means is that an identity that makes this person different to this other person. You understand? An identity that makes this person and this person different. Like I was saying, I was citing as an example that 2 people can share the same name, the same first name, the same surname, and the same middle name, right? So in that case, we must ensure that we have something unique to differentiate 2 of them. And in that case, we'll turn to the student ID or the employee ID in the case of the table we are trying to create. So in that regard, right, that student ID or the employee ID is a unique ID for on that table. You understand? That is, when creating this, we must always ensure that that column called unique ID does not have another person sharing it. It must be unique to that person you are giving it to. You understand? That is unique ID. I hope we are following me. Now, there is another constraint that we call primary ID or primary key. You know, we use those words together. Is it that you call it primary ID, or you say primary key, because they are also keys, or you say unique ID, you say unique key. You understand? Now, we have the primary key or the primary ID. Now, that primary ID or primary key is a combination of both not null and unique ID. Now, we say unique ID is a unique identifier on that list, right? And an ID given that makes this person different from every other person, because nobody will share that ID with him. Now, in a column, that you have a list of all the unique ID. In that column, you now also ensure that that column does not have an empty value. You understand? So you can see that there is a unique ID and that column is not null, right? So in that regard, in that case, that particular column has become a primary key. You understand? Because it is a unique ID and at the same time, it is not null. So I've explained 3 constraints, right? The not null, the unique key, and the primary key. And at the same time, we now have the foreign key, right? We have the foreign key. And this is a better way to understand the foreign key, right? Everything that we are doing now does not really explain the foreign key. But still in this SQL, we'll get to a point where you will understand the foreign key better. And what it's doing is this. Basically, we use the primary key. We use it to combine 2 tables together. Don't forget that in that database, we can have several tables, right? One of the things I also want to explain in Excel, I think we did cover that class, is when we're talking about power pivot, and I said the power pivot is used to combine 2 or more tables together. Remember that we're about talking about it. Now, when you bring the tables together, on this table, we'll look for a primary key. On the other table, we also look for what looks like a primary key. That is the key that we use to join both of them together. The same way it is in SQL. You understand? So when you have a primary key, you already know what the primary key is. When you have a primary key, we use the primary key to connect a table to another table. So the primary key on this table, you will look at that key. For example, now there is student ID on this table. For that table to connect to another table, it means that that other table must have a student ID as well. So you now use a student ID here to connect to the student ID here. That is when those 2 tables can now connect together. You can now begin to use them in one analysis. But student ID is here. Please pay attention as I'm explaining. Student ID is here. Student ID is there, right? On this first table, right, that student ID will be performing the function of a primary key. But that same student ID on the other table will not be a primary key again. It will be called a foreign key. This is how it is. I have a student table. Let's use employee and sales, right? So we have some set of employee in an organization. HR will capture their data, right, as employee ID, right? Now, we have those employees that are now that same employee in that organization that are working as a sales in the sales department. So when they make sales, there is a table for sales department, right? And that sales department, that sales table, we have sales ID. You understand? To manage the sales activity, right? And at the same time, because my name is Olamide, for example, my name is Maxwell, and I am a salesperson, right? So it means that as a salesperson, my information will be on that sales table. So the sales I make, we have a sales ID. But my own identity, I'll have an employee ID. So that sales table, we have sales ID. We also have employee ID. But in the employee table, right, I am an employee of that organization. So I have an employee ID in the employee table. So you can see that there is employee ID on the employee table, right? And there is employee ID on the sales table. So on that sales table, sales ID is the primary key. You understand? On the employee table, employee ID is the primary key. But employee ID is also showing on the sales table. So in that case, that employee ID is not, that sales table is not the owner of that employee ID. So in that place, employee ID is a foreign key. So if I need to join the employee table and the sales table together, I will use the employee ID here to join it to the employee ID that is on the sales table. So I'm using the primary key, the employee ID, that is a primary key here, to join it with the employee ID that is a foreign key in the other table. That is when 2 tables can be joined together, and you can use those 2 tables in one analysis. I hope you understand it. I'm stopping here to ask if you understand it. Now I've been talking. Do you understand this explanation of primary key, foreign key, unique key, and not. Do you understand it?
Yeah.
No,
I want to ask
Ah.
a question on it. Yes, I
Okay.
understand it, but I want to ask a question on it.
Okay, please do.
Okay, the question I want to ask on it, when you are joining them, and let's say, for instance, the employee ID is the foreign key on the sales table, like you explained.
Yes.
Now, if we need an information on the employee
Yes.
that is on the employee ID table, and we are on
Yes.
the sales ID table now,
Yes. On the sales table.
that means we will be able to automatically get it, even though we are not on that particular table, we are on another table, we are on the sales table now.
Yes.
But because it has been
Yes.
joined, we'll be able to get that information of that particular employee that is on another
Yes,
table.
because it will reference where it is joined to. Yes, we can get it.
Okay.
Yes.
Okay, that's what I want to be sure.
But the key explanation here is that the foreign key and the primary key look alike. You understand? The foreign key, but the positioning of those keys will define if it's going to be working as a foreign key or working as a primary key. You understand? So if you have an employee table, that key is a primary key on that employee table, right? On employee table, employee ID is a primary key on employee table, because you can see from the name employee ID, employee table. So it's a primary key, is the owner of that table, is a primary key. But if employee ID is showing face on a sales table, employee ID is not a primary key there, it's a foreign key there. And the reason why it is there is just the only reason it is there. Basically, the only reason why we always make sure that it is there is just to permit joining, is to permit relationship. And that is why you can see the definition that I put for it here. Foreign key, we say prevent action that will destroy links between two tables. So it's a key that prevents action that can destroy links. The function is just to permit a relationship to occur between two tables. I hope you understand. All right. So these are the 4 major constraints, right? But then there are some other major constraints, like we have the check, right? We check is just to the check helps us to know that to like say you are checkmating something, right? The check constraints help us to satisfy that this column that we are creating is satisfying a specific condition that we have created. You understand? That is what the check constraint is doing. But for the sake of to avoid ambiguity, right? We'll try not to make use of check for now. I mean, in this class, right? Once you understand every other thing, then to make use of all of those constraints will not be a problem. But to avoid ambiguity, so that we don't have so many things together on our head, we'll try to avoid the last three, the last three constraints, right? But then also this create index, right? It's used to ensure that the database work fast. You know that there are some things that you do on for example, we have two systems. You do something on the system. If you do that same thing on another system, it can drag. You understand? So the action of create index constraint is to manage the rate at which data are retrieved, from the database. So it's just that we use the create index to manage how fast you get response, your outcomes come, and all of that, right? And also default is to set some values as default value. But I intentionally don't want to measure explanation on this 3 of them, but just ensure to understand that we have some things we call SQL constraints, right? That helps us to set some rules to our data, on the in the database. All right. So let's get back to our workbench. Our time is fast spent, right? And we are trying to create a table, right? So you can see now we said create table. Obviously, we can't move beyond creating, we can't move beyond the create statement for today. We'll continue from there on Sunday, right? So we have create table, right? I mean, to create a table, write the statement create table. Then we'll put the name of the table, Then we'll put all the columns of that table. Now we have written a column, student ID, right? Student ID. Then we'll put the data type and the length of that data type. If we need to put another constraint, we'll put the not null. For example, we are putting the not null constraint, right? Then if you want to put another constraint to say that student ID should be the primary key, we can also do that, right? So you can keep putting more constraints to say that same table is going to be the primary key. Just write primary. That's all, right? But then I don't want to put more things, Now, I do comma. That is, I have created student ID column. I'll write the second column, right? We said another column will be full name, right? So we write full name. Don't forget I said that you can't put a space bar. So we have full name. All right. We have full name. And then the full name will always be Vaka, right? Will always be Vaka, right? And then the length of it, let's say 50, right? 50, yes. Yes, we have created full name column, comma. What's the next column that we want to create? I want to have registration date, right? So let's call that reg date. Let's call it reg date, registration date, right? And then what is the data type that this will be? This should be a date, right? This should be a date, right? And then that's how to write a date data type. The next thing is gender, right? We also have the gender. You can see now we are specifying the column, right? Gender, and what should be the data type? Let's use a car, right? Car. And then we want to use acronyms for the male, M for male, F for female, right? So it means that the character, the length will be 1. Is that not so? Yes. And then what's the last column that I want to create? Phone number, okay? It's not the last. We still have phone number. So let's call it like this, phone number. What should be the data type? We can use a car also, yes, because it's performing the work of an identity, like we explained. So we can use a car, and we know the length of a phone number. That should be 11. Is that not so? I'm using Nigeria as an example. Phone number in Nigeria is 11, all right? And then lastly, what's the last thing we have? The department, right? So we have department. And that should be, let's say we're writing as DPT, department, right? Or let's write it in full, department. And then department, what should it be? Department is spelled department. You must be careful of spelling department. What should be the data type? And let's use Vaka. Let's just use Vaka because we don't know how long the department will be. And let's give it Vaka. Let's say Vaka 30, for example, right? And then this is the end of it. This is all the table that I want to create, right? And lastly, we'll come to put semicolon to mean that we have ended it. But look at all of this, right? You will see that something is wrong with it, right? You can see that we have this red thing. So it means that something is wrong with, so we'll try to find the error. Number one, at this point, I'm saying that my comma is having that line. You can see that there's a red line under this comma. So there's an issue here. They say that there's a missing key, right? There's a missing key. Of course, it will always suggest what the error is. So the constraint, primary key, is not primary. That's what it's trying to tell me, that it should be primary key. You understand? Of course, I intentionally left that there so that I can show you that there will be an error. Now, so it means that at that point, is advising me that no, I want to put a constraint to say that student ID should be a primary key, right? But I didn't write the primary key. It doesn't recognize primary. What it recognizes and what SQL recognizes is primary key, and I must write it in that order. Yes, sir.
Please, as I make the correction, it's clearing all the other queries. How do I avoid that?
Which correction?
Like that, as I added the key, the full name was cleared.
No, it shouldn't be.
It shouldn't be, right?
Yes, so maybe you clear it from the beginning and write it again.
Again.
Yeah.
All right, thank you.
Then I also want to ask a question.
All right.
The place where your cursor is now on full
Yes.
name, between full
Yes.
name and primary key, do you have a space bar
Yes.
there? Because it looks like
Yes,
there's a space bar.
I have a
Okay,
space bar.
so-
If you didn't put a space bar, no problem. But I have a space bar.
Okay, because you were saying that we can't put space bar between full and name. We must use an underscore.
Yes.
So,
No.
but
Now, you can
between
see
the
that.
primary and key, there's space bar.
Yes. Yes. To move to the next thing, there's a space bar. But then, if I put a space here, you can see that is already, because name is an identifiable keyword in Excel. So it will not be seeing these two things as full name. It's seeing them as you are trying to write a keyword.
Okay.
That already exists in, not Excel, that already exists in SQL.
SQL.
You understand? So that is why there's always care when you are trying to write a single word. So we don't separate single word by space, because the other half of it can actually mean something else in SQL. So we prefer to say, okay, let's put it together, or you put an underscore, or you can also put an hyphen if that's what you are. In fact, hyphen is not even allowed, because hyphen is not allowed, because hyphen is a clause that we're still going to get. We are still going to get it. So use an underscore, right? Right.
Okay.
That is that. Now, yet it is not still correct, right? It is not still correct. If you come to this place, there is an error somewhere also. There's an error somewhere also. Now, somewhere here, there's an error here, right? What is the error here? I have department, VACA.
I think there's a space between that after VACA 30. After VACA 30.
After what?
After department.
No,
VACA
there's no
30.
VACA 30. There's no space between VACA 30.
After the brackets, there's
no
a red thumb under after the brackets.
Yes. Yes, that's why it's showing us that there is an error there. But then the error that is there, we have not identified it.
Right? It needs a bracket again to close a closing bracket.
Thank you, sir. Thank you. That is the error, right? This bracket that is here is closing this particular bracket. Now, there is a bracket that we have opened from here. Can you see? Student info, we open the bracket. So that bracket needs to be closed. Thank you, sir. That is the. So I just want us to follow. So now that I put it, you can see that it has closed everything. Now, we now have the blue dots. Thank you, sir. Thank you for being, vigilant to discover that. So like I was saying, every area of that statement is important, and you must pay attention to it. So when you see that it is telling you that there's an error, it doesn't mean that you are totally getting astray. You just only need to focus on, pay attention to some important things in there and write them in the right order. Now, before I execute, you will see that our statement is already getting longer and it is taking the screen, right? So this is what I always advise, right? This is what I always advise. Let's get to the beginning, okay? This is our beginning. Now, you can use spacebar to break them and it will not affect your line. For example, I say create table student info, right? I can break it here and come to the next line, right? So far, I didn't put semicolon here to say that I have ended my statement. Everything is still one line, even though you break it. You understand? So I can say now, I have the first line is student car, this, blah, blah, blah. That will stop here. I can come here and break it. So the second column is full name car and it stop here, right? I can break it from here. So I can keep breaking it so that I don't have one long language that will overtake my screen. All right. So some people prefer to have it long like that, but I don't prefer it because it means that if I need to read, I'll have to be moving, across the whole screen. So I don't prefer it that way. So there's no standard, it's just preference. So nothing special there, right? So I always prefer to break it like that. Yes, and I can come to the end of it. So everything you have here is one statement. You can say now it's long, but it is one statement. You only need to understand what is.
But I think it's better for a beginner. It helps you to know each of those steps.
Yes, sir. So somebody is asking, please, sir, can you complete this very class event? Okay. Of course, we'll be done. Thank you. All right. what am I saying? So we have written a statement to create the table. Now we are done. You can see that everything is correct. We can now execute. So look at it. Look at it. I will click this execute button to say execute, right? And then it has not executed. Yes. And you can see now it has executed. Look at the action output. Now I say that on this date, I executed this statement, right? And message is very role affected. There's no issue anyway. That's what that means, right? And I'm good. So I have created a table under the database, right? And this is where we're going to stop. But before we go, we need to see the table we have created and see how it looks like. Don't forget that we have not begun to insert values into the table. We have only created a table. Now to see the table, we use another clause now. We use the create clause to create. Now to see the table, we use a clause called select. So we have talked about create. Now I'm bringing another clause to you called select. So I want to see the table, right? Now, using select, we can say that select only the student ID. That if that's the only thing you want to see, you want to see only the student ID, right? In that table, you can say select student ID. From the way the syntax is written is select, mention what you want to select from where you are selecting it from. So you select a column from a table. You understand? You can only, because a column is a part of the table, right? So we'll say select. So why somebody is asking, why do I skip line 10? Of course, I may decide to write it together. Nothing, no issue, right? But I like some things are my preference, right? Right? Maybe you may want to understand it that way, just to bring sanity or neatness into the structure of what you are writing. You understand? So that two things don't look jam-packed together, right? Now, I want to select, I want to see what I have written. So I say select. This time around, I want to see all the columns. I'm not interested in seeing only one, maybe only one column. I want to see all. Now I'll say select, right? Now to say select all, I can say select student ID, full name, registration date, and list all of them from, okay, let's just do it that way. If I want to see the student ID name and full name, student ID and full name, I'll say select student. I know our time is past, please. We can't stop midway here, right? Student ID, we'll stop very soon. Select student ID. How many things do I want to see? I want to see full name also. Select student ID, comma, full name, right? Only two of them. From, you can see that from is blue color also because it's an identified statement in SQL. Now you must state, don't forget I said it's like you are writing English. So select, you have mentioned what you want to select. Where are you selecting it from? So it's always from a table. And what's the name of that table? Student info. So select student ID, comma, full name from student info. You understand? Then use semicolon to say that I'm done writing my statement. You understand? Then you execute. And let's see what we have. So it's giving me an error. Select student ID, unknown column, student ID. That is, this student ID, the column does not exist. Now, look at it. Why is it not exist? Let's see if I spell it well. Look at how I spell student ID here. Look at how I spell student ID here. You can see it's wrong, Abby. That's why it's saying that. Thank you. It doesn't understand it. So let's be sure that what I've written. So let's run it here now. All right. All right. You can see now. So it has given me those two columns out of. Now, this is okay. Before going to say what I want to say, now I'm seeing only student ID and full name because those are the things that I say I want to see out of everything I've created. If I want to see all of them, I can cancel this from here, right? If I want to see all of them, right, everything I've created, and I don't want to write it all of them out like that, I can say select all, right? So I will say select that all. I don't write it as all. In SQL, when you see the sign asterisk, it means all in SQL. So if I say select all, can you see? Select asterisk, it means I say that select all from what? From student info. Select all from student info. So if I put a semicolon to end it and I execute, can you see now? My output is saying that everything is good. And now you can see the table I have created. These are the columns. You understand? Column student ID, full name, registration date, gender, phone number, and department. But there's no value. We have not put the name of those persons. That's why it is like this. We have not filled it. So one good thing about, if you look at this statement here, I only call out only two, student ID and full name. So one good thing about SQL is that you only see what you want to see. Imagine if I open this one on Excel. Once I click the Excel, everything that is there will just open for me. You understand? But in SQL, because SQL can take too many data, so the query language will only permit you to call out the only thing you need from it. Now that I said I want to see all of them.
Sorry.
All right. Please ask your question.
Okay, the first time you said select, yes, thank you. The first time you said select student ID and
yes.
Full name. You selected just to full name and student ID. Now we saw only that too. You didn't wipe that one away. You didn't clean it. On the next line, you now selected all from student info. Now the first two that came, I thought they were supposed to be different from the whole table. Now it looks like everything now joined together. Is it that the last argument overrides the previous one?
Thank you. The last argument, once you have
stopped your line 11 now, your line 12 or so.
Yes. Once you have put in this column here, it means that this statement has stopped there. We have executed it. So everything behind had no meaning. Even if I go ahead to cancel all of this, it doesn't make any impact again. I have executed it and it has been registered. Do you understand it? Once you have executed, once you have executed, the statement that is in the past is just there. Nothing is. If you go there to go and cancel anything, it's not making any effect. So I have executed this. That is, it has gone. So the relevant statement now is the new one that I want to write. Do you understand it?
Okay.
Yes, that's how it is, right? Any other question? I want to stop around there. I want to stop here. Any other question? Okay, why we are still looking for the...
So whatever is displayed is the last execution done.
Is the last execution done, sir?
Thank you.
Yes, sir. So look at this place now. Now, if I come here now, you can see that once I come here, the table is still there, right? Now the table does not really have does not still have this another drop down here, unlike this one. Right? Where's my awesome chocolate? Yes. Awesome chocolate. You can see that the table still have drop down to see that there are many other tables. So it means that on this same amplified database, I can still create another table. You know, I call this one student info, right? Let's say if we are taking this to be Agape's database now. So we can have a table that speaks to, for example, permitting to use, for example, offerings. You understand? Maybe offering, maybe at that time we'll have maybe IG, offering IG. We'll have the name of the people that are making the offering, the amount they make, the name of the offering, whether it is a Sunday Thanksgiving or tithe, all of that. That is a table. We can also have another table to be membership ID, membership table. You understand? Like the one we're always generating that link to feed. That will not have members. In this case, now we must have a member's ID. Every member must have an ID for easy identification, right? We have member ID, we have first name, other name, we have the department they are in the church, we have the day they done the church, out of that. So we can have multiple tables under that database that would have called Agape or Agape Ogbenfako. You understand? And all the tables will be listed under the database called Agape, or we call it amplified. I hope you understand it now. We'll still create multiple tables, right? And we are still going to see how to join the tables together. I've given an hint that we need the primary key and a foreign key to join them. But then we are still going to major them as a topic under this SQL, right? But then to this point that we have, do you have any question? Because I think we should end the class by now. Any question? Okay. If there are no questions, let me also include that. Okay. Let me not bother about that so that we don't prolong the class. So, if there are no questions up to this point, I'm still waiting to see if you have questions. But then, if there are no questions, I think it's a good time to call it a day. All right. Thank you, class. I hope we have. I hope you understand the few things that I've explained so far. I hope.
Thank you very much.
All right. Thank you. So I will go on the video and share if you need to look at it again. And then from now, you'll see that we will begin to write, because at the time that we are now not writing queries, right? Begin to see how to write more queries. There are a lot of queries that we're going to write. All right, thank you very much. Thank you very much. Somebody say, okay, thank you, sir. Thank you, sir. Also,
thank you, sir. Thank you very much.
You can call it.
Thank you very much.
Have a very well. Yes, sir.
Good night, everyone.
Thank you, sir. Good night, sir.
Good night, sir.